In this lecture, we'll learn how to simplify algebraic expressions. Let's just recall what we said from the last lecture. A variable is a letter, typically x or y, that represents some number, and an algebraic expression is a sum, difference, product, etc., consisting of a variable or variables. So for example, x plus x squared plus x to the third power is an algebraic expression. We can also have 2 plus x, or x plus y, or 2 plus x over 1 plus x. These are all examples of algebraic expressions. If we have the expression 2x plus 3x, we can simplify it into 5x. This is because 2x plus 3x equals 5x. What this means is that for any value of x, no matter what we pick, if we substitute it into the equation 2x plus 3x equals 5x, it will be true. Therefore, we say that 2x plus 3x equals 5x. So the algebraic expression 2x plus 3x can be simplified into 5x. The number in front of the variable is called the coefficient. Therefore, the coefficient of 2x is 2, while the coefficient of 3x is 3. One way of simplifying algebraic expressions is by combining like terms. Let's illustrate that in an example. Let's simplify 2 plus 3x plus 6 plus 4x. We can combine 2 plus 6 to get 8, and we can combine 3x plus 4x to get 7x. So we're left with 8 plus 7x. We cannot combine 8 with 7x as they're different terms. They're not like terms. When combining like terms, we need to be careful that the terms are similar. Since 8 does not have a variable x, we cannot simplify 8 plus 7x any further. The same idea is also true when we have to subtract like terms. We should subtract them similarly with how we subtract regular numbers. For example, let's simplify 4x plus y minus 6x plus 2y. Note here that we have two variables. The like terms are the 4x with the negative 6x and the y with the 2y. These are the terms we will combine. We will combine 4x minus 6x into negative 2x because 4 minus 6 is negative 2. How do we combine y plus 2y? Here's a useful trick. We can think of y as 1y because 1 times anything does not change it. So 1y equals y. Therefore, y plus 2y is the same as 1y plus 2y, which is 3y. Our original algebraic expression simplifies to negative 2x plus 3y. Note that we cannot simplify this any further because x and y are different variables, hence different terms, so they cannot be mixed together. Maybe the following computation will illustrate why we can't combine unlike terms. Suppose we wanted to add 2 feet and 3 inches with 3 feet and 5 inches. When we combine these lengths together, the answer is 5 feet and 8 inches. We can combine the feet with the feet and the inches with the inches, but we do not mix inches with feet when we add the numbers because they're different kinds of terms. Our final answer is 5 feet and 8 inches, and we can't simplify this any further. This is a similar idea with combining like terms in algebraic expressions. This is why we combine like with like only. A common mistake is to confuse x and x squared as like terms. The confusion comes from that x and x squared are both in terms of the variable x. Thus, it's a common mistake to try to combine these terms. For example, 2x plus 3x squared cannot be simplified further. These are not like terms. Some students make the mistake of combining x with x squared and think that it's x to the third power, so they would write 2x plus 3x squared equals 5x to the third power. This is wrong. Anytime you're not sure whether your simplification is correct or not, substitute some numbers into it and see whether or not they are correct. For example, if we let x equals 2, then we see that the left-hand side is different from the right-hand side. So 2x plus 3x squared is not equal to 5x to the third power. So we cannot simplify this expression any further. The same is true for other powers of x, such as x to the second, x to the third, x to the fourth, and so forth. They are all separate terms and cannot be combined as if they were like terms. So far we know how to add or subtract two algebraic expressions together. We will next learn how to multiply two algebraic expressions together. Recall that x to the second power, or x squared, means x times itself 2 times, and x to the third power means x times itself 3 times. For example, 3 squared, or 3 to the second power, is 3 times 3, which is 9. And 4 to the third power is 4 times 4 times 4, which is 64. The same is also true for other powers. In general, x to the p, where p is the power of x, means to multiply x by itself a total of p times. Say we want to multiply 3x times 2x. We multiply 3 times 2, which is 6, but the x variable we combine into a square, since x times x equals x to the second power, or x squared, so we can write 3x times 2x equals 6x squared. Another example. Let's multiply 4x squared times negative 3x. We know that 4 times negative 3 equals negative 12. Now we need to figure out what x squared times x equals. Remember that x squared equals x times x, so x squared times x equals x times x times x, which is x to the third power. Therefore, the answer is 4x squared times negative 3x equals negative 12x to the third power. Another example. Let's multiply negative 2x squared times negative 5x to the third power. When we multiply negative 2 with negative 5, we get positive 10. It remains to determine what x squared times x to the third power is equal to. As before, x squared equals x times x, and x to the third power equals x times x times x. So x to the second times x to the third is x times x times x times x times x equals x to the fifth power. Therefore, the answer of negative 2 to the x power, to negative 2x squared times negative 5x to the third power is 10x to the fifth power. The above two examples illustrate a general rule about multiplying powers of a variable. If we want to multiply x to the fifth by x to the ninth, we simply add the exponents to get x to the 14th. Let's generalize this rule by saying that x to the a times x to the b equals x to the a plus b. How do we multiply different variables, though? Say x times y. As you can probably guess, there's no way of simplifying something like this. We just have to leave it as is. Here's a bit of notation. We often drop the multiplication symbol and just write xy. The two variables being together indicates that they are being multiplied. Let's look at an example. Let's try to multiply 2xy squared times x squared y. First of all, we can put a 1 in front of the x squared y rather write 2xy squared times 1x squared y. This step is not necessary, but we're doing it because we want to make it clearer to follow what we're about to do. As we did in the previous examples, we multiply like terms with like terms. So 2 times 1 equals 2. X times x squared equals x to the third power. And y squared times y equals y to the third power. Therefore, we write the answer as 2x to the third power, y to the third power. Note that we don't put a multiplication symbol between x to the third power and y to the third power, because whenever two variables are next to each other, the notation means that they are being multiplied together. Until now, we've discussed how to add algebraic expressions and how to multiply them. Now we'll combine both of these together. For illustrative purposes, we want to simplify the algebraic expression 2x times x plus 1. How do we do that? Here we need to recall an important rule between multiplication and addition called the distributive law. It says that a times b plus c equals a times b plus a times c. Again, the letters here are variables. They can be any numbers. For example, 2 times 3 plus 4 is the same as 2 times 3 plus 2 times 4. Check that both sides are the same. This fundamental law links the relationship between multiplication and addition. We apply this law above to the original problem we posted. Say we want to simplify 2x times x plus 1. We do this by the distributive law of 2x times x plus 1 equals 2x times x plus 2x times 1, which equals 2x squared plus 2x. For example, let's simplify 3x times 1 minus x. Again, by distributive law, we find that 3x times 1 minus 3x times x equals 3x minus x squared. Suppose instead the problem was negative 3x times 1 minus x. Then we start similarly, negative 3x times 1, and subtract negative 3x times x. Here we need to be careful about what makes many students get the wrong answer. There are two terms, negative 3x times 1 and negative 3x times x. The first term is easy, negative 3x. The second term is negative 3x times x, which is negative 3x squared. However, and this is important, there's also a minus sign connecting these two terms. So we get negative 3x minus negative 3x squared. Because of the presence of two negatives, we can simplify this expression to negative 3x plus 3x squared. Another example. Let's simplify negative x minus y. An extremely common mistake for students is to drop the parentheses and put the negative in front of the x. The following answer, though common, is wrong, negative x minus y. To see why, introduce the number 1 as a multiplying force behind the parentheses, as multiplying by 1 does not change the value. Consider negative 1 times x minus y. Now open the parentheses by the distributive law, negative 1 times x, and negative 1 times y. The first term, negative 1 times x, is negative x. The second term, negative y times y, is negative y. However, since there's a minus connecting the two terms, we get negative x minus negative y, or negative x plus y, because of the double negative. The exact same idea is also true with negative x plus y. The answer is not negative x plus y, rather it is negative x minus y. And to see this, let's again introduce the number 1 in front. Consider negative 1 times x plus y. This becomes negative 1 times x plus negative 1 times y, which is negative x plus negative y, which is the same as negative x minus y. Because a positive multiplied by a negative is a negative. That's why plus negative y ended up turning into negative y. Let's look at another example. Let's simplify 3 times x minus y minus 2 times x minus 2y. First, 3 times x minus y is 3x minus 3y. Second, negative 2 times x minus 2y equals negative 2 times x minus negative 2 times negative 2y equals negative 2x plus 4y. Now we combine positive 3x minus 3y minus 2x plus 4y equals a total answer of x plus y. In the left side of the expression, we had a total of 3x, and in the right side of the expression, we had a total of negative 2x, which equals 1x altogether. In the left side of the expression, we had a negative 3y, and in the right side of the expression, we had a total of positive 4y, which again equals positive 1y. So the total answer is x plus y. Next, let's take an example where you have two terms multiplied by two terms. Let's simplify 1 times x plus 2 times x. Because the entire term is being multiplied by the entire term, each term on the left side has to be multiplied by each term on the right side. We do this by sometimes referred to as the FOIL method. For first, namely the first two expressions multiplied by each other, then the outer two expressions multiplied by each other, the inner, which is the inner two expressions multiplied by each other, and the last. In this case, the first expressions are the 1 and the 2. The outer are the 1 and the x. The inner are the x and the 2, and the last are the x and the x. So what you have altogether is 1 times 2, which is 2, plus the outer, which is 1 times x, which is x, plus the inner, which is x times 2, which is 2x, plus the last, which is x times x, which is x squared. Of the four terms, only two of them are like each other. Those are the middle two terms, the x and the 2x. So we can combine those two terms to make 3x, for a total answer of 2 plus 3x plus x squared. For another example, let's simplify x minus 2 times x plus 3. The first expression is x times x, which is x squared. The outer is x times 3, which is plus 3x. The inner is negative 2 times x, which is negative 2x. And the last is negative 2 times 3, which is negative 6. Again, the middle two terms both have the same variable, x, and so they can be combined into 3x minus 2x, which is x, for a total answer of x squared plus x minus 6. Next, let's simplify x minus 1 squared. Now, an entire parentheses squared, like s minus 1 squared, is the same as x minus 1 times x minus 1. It's an extremely common mistake for students to write x squared minus 1 squared and assume that that's the entire answer. But what you need to do is multiply two entire parentheses of x minus 1 together. The first term is x times x. The second term, the outer term, is x times negative 1. The inner term is also negative 1 times x, and the last is negative 1 times negative 1, which is positive 1. So what you get is x squared minus 1x, or x, minus another 1x, or x, and then plus 1, for a total answer of x squared minus 2x plus 1. If you have three terms, a trinomial by a binomial, you have to do the same procedure, except that each number in one parenthesis has to be multiplied by each number in the other. For example, let's simplify 2x minus 1 times x squared minus x plus 1. Each of the terms in the first parentheses have to be multiplied by each of the terms in the second parentheses. It doesn't matter which order you do it, because you're going to combine like terms eventually anyway. So let's do the first one. 2x times x squared, which is 2x to the third power. Then 2x times negative x, which is negative 2x squared. Then 2x times 1, which is positive 2x. Now multiply everything by the negative 1. Negative 1 times x squared is negative x squared. Negative 1 times negative x is positive x. And negative 1 times positive 1 is simply negative 1. And what you end up with is 6 terms. 2x to the third power minus 2x to the second power plus 2x minus x squared plus x minus 1. Now let's look for what combinations we can do. The second and fourth term, the negative 2x squared and negative x squared, are combinable because they have the exact same variable, the x squared. Similarly, the third and fifth terms, the 2x and the x, are combinable into x plus x, which is 3x. And of course the last term has no variable, so it's not combinable at all, for a total answer of 2x to the third power minus 3x to the second power plus 3x minus 1. So in this lecture, we talked about how to simplify algebraic expressions consisting of addition and multiplication. In the next lecture, we'll talk about how to factor certain algebraic expressions. Factoring means writing an expression in terms of a product. Sometimes it makes certain problems in algebra easier when we can factor an expression. This is an important technique that we'll discuss in the next lecture.